Filip is here. Hi, Filip.
Hey, yeah, just give me a moment. I'm kind of trying to set up here. So, can you hear me okay?
Yes, it's great.
There,
So
awesome.
I would like to introduce next speaker. It's Filip Babic. Did I pronounce correctly?
Yeah, perfectly.
And we'll talk about developing open source accessibility library for Android.
Okay, let me just share my screen real quick. Can you see my screen okay?
Yes, I will
Oh,
share.
there it is. Awesome.
And yeah, you can start. Good luck.
Okay, thank you. Well, thank you everyone for joining my session today. I know it's a Saturday, so a lot of you might be still sleeping or kind of, half asleep, or it might be a bit later for you depending on your time zones. Either way, thank you for joining. So today I'll be talking about my thesis project for my master's degree, which is also kind of I believe, a nice story about me developing an open source accessibility library for Android, which is called Ally. If you want to know a bit more about me, I'm currently a video instructor at Raspberry, which is the company behind RayWearly.com. If you haven't heard, we're a pretty popular educational portal for iOS, Android, Unity, Server-Side Swift, and Flutter, of course, and a lot of different other things where you can just learn about programming from experts, from people who work at Google, Amazon, Microsoft, Apple as well, all of these big companies and many, many other. I've been an Android developer since 2015, something like that, so about 5 years now. I do a lot of content creation, so I have a personal podcast about IT in Croatia, which is currently just in Croatian, so you might not be able to understand it. I write books, I write tutorials, and I record video courses, as you can see behind from my green screen and everything, which is currently my job, as I mentioned. But today we're not here to really talk about me. We're here to talk about some different things about us as developers and about our community, our audience, our users. And if you don't know, this is a really staggering number. More than 15% of the world suffers from at least one form of disability. So this can either be a physical disability where you have, let's say, some muscle atrophy, or you just have a part of paralysis or a paralysis on a part of your body, so you just can't either move or use your limbs in a way you would usually use them, so you can't really use your hands properly or your feet or your legs, sorry. Or it might be a more censored disability, meaning that you either have some visual impairment or hearing impairment or something else. So either way, more than 15% of the world suffers from at least one of those disabilities, and about 2 to 4% suffer from severe disability, meaning they can't really, do everyday things on their own, as some people who don't suffer from those disabilities can. And it's even more staggering when you think about it in terms of our development community and also our audience or our user base. So this is a statistic from 2019, so it might be even bigger now. The number might be even bigger. But basically it says that more than 2.5 billion people use Android, which is about 75% of the market, meaning that over almost 4 billion people in the world use mobile devices. And this is, as I mentioned, a number from 2019, so this might be even more. So if you pair this up with the previous statistics, this means that there's over 600 million people who suffer from disabilities, and these people are within our audiences. This is our market, even though we may not always be thinking about them. And this means that a lot of our users have disabilities and can't use our apps to their full extent. But there's a way to kind of defeat these numbers. There are different ways we can try and help those people to use our apps or develop our apps in a different way that's just intuitive to use for different kinds of modes within our operating systems. I'm currently talking about Android, which is my choice of platform, but you can also use all of these things on iOS and on web-based technologies or just general desktop technologies. Sorry. And we can defeat these numbers. We can apply something called software accessibility, or in general just accessibility, but based on software. And it's a way to help us develop applications which are more inclusive and accessible towards people who suffer from those disabilities. So, if you if you've played video games or like watch videos and stuff like that, you usually have this thing called colorblind mode, which helps shift the color spectrum in the entire screen. Sorry, on the entire screen, to shift it in a way that people with color blindness can view all the colors instead of just seeing different hues of depending on their color blindness. So either 2 or 3 colors. So this is one of those modes that you can use and develop for to make your applications more accessible. But there are a lot of different ways you can use them, and we'll kind of go over that in a bit. What I want to say about accessibility in general is that developers and UI or UX designers generally look for ways to build applications which are foolproof. And the term is kind of not that positive, but it basically means that any person who may not be so tech savvy, may not generally know how to use applications, may be a bit older, so this technology is a bit out of their time, so to say. Any person should be able to use applications just by looking at them and using them intuitively. This means that the applications are foolproof in a way that any fool, so to say, and I do admit it's kind of a bad term, but any fool can use the app, right? But we don't really think about applications to be disability proof. So this is where accessibility comes in, and as I mentioned, it's a way to support everyone, not just the average Joe user or the average person who is completely healthy and knows enough about technology to use our applications. We should be able to support different audiences as well, and to make our applications more inclusive. And as I mentioned, accessibility is that feature or that part of developing applications and products that make our apps more inclusive. Accessibility is also known as A11Y or A11Y because there are 11 letters between A and Y. So just for a shorthand, I'll say LI, so it's a bit easier to understand. And LI is no more than a set of guides, or set of rules, set of different tools you can use to support those different modes in our applications. So as I mentioned, the system has generally native support for colorblind modes. When you develop video games or video or image heavy content, you usually want to support such modes as well. So it's kind of like a UX guideline that help, just like UX guidelines help average people use your applications or navigate your applications. Accessibility or LI is UX for people with disabilities. And some of the modes there are currently in most operating systems, I would say, are screen readers, which are ways to read text and general content actually from the screen, just like the name states. So it can be internal software in the OS that reads all of your text messages out loud, or it might even read descriptions behind images if you suffer from full visual impairment, if you're fully blind. So you can see those images, but you can provide a description that the operating system reads for you to kind of understand what the description is. So if it's an image of the ocean and there's children playing, your description might be something in the manner of this image represents an ocean, a sand beach with 3 children playing, building sandcastles, something like that. So this would be what the screen reader will say to you. There are also some different features as well, such as text-to-speech and speech-to-text, which is a way to either read out just pure messages and not image or video content, or ways for you to talk to your phone in order to write messages. So if you suffer from any kind of motoric impairment, so you can't really use your hands properly, you can't write using the software keyboard or some other external hardware keyboards, you can use your voice to write. There are different also modes here, such as UI scaling, voice assistance, gestures, focus navigation, and some other which are more complex but are not really in software. But the key thing about all of these modes is that all of these features exist in pretty much every operating system, but not every application is supporting all of these modes, and that kind of creates this problem where we have applications which are not accessibility friendly. And in terms of Android, there are different ways we can kind of try and support accessibility, or sorry, there are different tools that help us support accessibility. The first is the Accessibility Scanner application, which is an external application from Google that you install from the Play Store. You give it some permissions, and you give it the permission to draw over other applications. You run the application, and it basically takes up a different process and lets you take screenshots of different applications in order to scan all of these different issues. This means that once you take a screenshot of a list, for example, it will give you a list of issues saying, hey, this item might have an issue with their content description, like these images, or this text might be too small, and something like that. So it takes a lot of manual work, a lot of time to actually set these things up, but it gives you this sort of UI where you can just take a small screenshot, have a look at all the different ways the application might be failing in terms of accessibility. It also gives you different suggestions on how you can increase or help the accessibility support. In this case, for example, this text has a low contrast, meaning that it might be harder for people with color blindness or any other kind of visual impairment to read this text behind a very dark gray background. So the suggestion might be to increase this text contrast, or by increasing or like making the color a bit lighter, so there's a bigger contrast, or just to change the background to just be a bit more lighter, or some other different way to support accessibility. And there's this different tool that's called Accessibility Test Framework. It's a completely different thing composed to Accessibility Scanner. It's actually a framework built on top of the JUnit framework. So it's a set of different tools that you can use to run accessibility tests accessibility checks in each of your tests. So you basically plug it into your UI tests, and as they run, you get to scan accessibility checks automatically, and your tests fail if there are any kinds of issues. So in this previous example, if you ran a test, or if you run a test for this screen, the accessibility framework will check that you don't have a good enough contrast with this text view, and it will fail your test saying that. So it's a more automatic way where you don't have to write a lot of, you don't have to set up the application, you don't have to take screenshots and manually go through the thing. You can just plug it into your tests and then run your code. It also has some different things where you can suppress or test results. So you can say, hey, I have this text view which I don't want you to test. So this is really useful when you don't want the entire build process in your CI or CD to fail because you have a single small accessibility issue that you can't really get around to, or it's actually a view that you don't really want to use for accessibility. So it might be different kinds of things, but you can suppress different checks. Again, this is a much better solution because it's more automatic, but this requires of you to have UI tests for every single screen in your app, because you just have to run them. Also, as we know, UI tests run a bit more slowly compared to general tests. So this takes a bit more time when you want to run a whole suite of tests for every single screen. And then, as I mentioned, a single test might, and a single accessibility issue might fail all your tests or your entire build process, where you have 5, 6, 100 tests or even more for your entire application. So it's very susceptible to issues, and it's not, because of this, it kind of slows down your development time. And this is where Ally, which is the name of my library, so it's not the accessibility abbreviation, comes in. And the library I developed, which is called Ally, is an open source Android and Kotlin-based library, which aims to help developers keep their accessibility in check. So it means that as you develop your applications, you plug in Ally, and it scans for different accessibility issues and gives you those reports. I generally think about it as leak canary for accessibility. So as you go through your app, as screens are being destroyed, so in the onDestroy callback, every view is being scanned and a report is being generated. So it kind of generates or catches all of the issues you might have in terms of accessibility within your view hierarchy. And as I mentioned, it scans the entire hierarchy, so it's bound to not miss a single view, or bound to catch everything. And it's not just about scanning for issues; it's also about reporting them. So what it does is, after the onDestroy callback, or within the callback itself, as the current view of the hierarchy is being scanned and the report is being generated, it also uses that report, which is kind of a bit more complex. It's like a whole tree of reports. It flattens it to a single linked list of reports, and then it prints it out in a file, letting you know about all of the issues and where they happen, which is really important because it's not so easy to find and fix those issues if you don't know where they happened and you only know that they are there. So some of the issues that Ally detects, and I put an asterisk here because it's not fully, I wouldn't say it's not fully developed, but it's not still in 1.0. I'm not still entirely happy about all the features I managed to put in. So currently it scans for general text issues, edit text issues, image view issues, and general view issues. So things like the contrast between the text and the background, about the text size, autofill and general hints for edit text, content descriptions for image views, and size and touch areas for views. So all the, let's say, important things, all of the things that are most common in applications. So it scans for all of these issues and detects them appropriately, and then generates a report for you. I say it's not in 1.0, so it's not like fully stable, so to say, but it is stable and it works and you can use it. The only issue is that I'm not still fully happy about the amount of features that I managed to get into the small period of time I got in developing the application, or the library, sorry. So I'm just trying to kind of polish it out, add more features, add more checks, and make the entire thing a bit more flexible, so to say. And I'll kind of talk about that a bit later on. So let's kind of see how it works. The main class within Ally in terms of data is the report class, which holds the parent ID, the type of the parent that you're kind of reporting on. So a single view group. It generates or gives you a list of view reports for that parent or that container, so to say. So if you have a linear layout with 3 text views and all three have issues, you would have a report which the text issues in that parent linear layout, and it will give you the linear layout type, and it will give you a list of reports for those 3 text views. The important thing here to note is that it also has a recursion built in, so to say, where it has a list of child layer reports, because each container in Android, each view group in Android can hold any number of other view groups, meaning that you can have any number of nested layers, which is here represented by the child layer reports. So within the linear layout, you might have another linear layout or frame layout or something else, and this would give you a list of that one nested container. Now, the issue with this is that in theory, the trees can be as complex as you would like them to be, or as complex as you need them to be. And this is very, very hard to analyze and print out, because printing out a tree is much harder than printing out a list, so to say. So this is why I have a special algorithm within the library that takes those child layer reports and flattens them out to a single report called the next level report. So you have level 1, which is the linear layout. You have level 2, which is let's say the frame layout. And then if the frame layout has more levels, you will go to level 3 and so on and so forth. But basically this means that from a tree report, or a report of trees, sorry, trees of, I'm kind of confused here. But basically a single report that holds more reports forming a tree of reports, you get a single linked list of reports, which is much easier to go through. Each of those view reports has, again, the parent ID and type of where they are located in, so you can find them, and what the actual view has is, or what the actual view has an issue. So in terms of its ID and its type. It also has the view report item list, which is basically a list of all the issues for that view. So every single view can have multiple issues. A text view can have the issue of not being visible enough because of its contrast, because of its size, but it can also have the issue of not being clickable enough in case you use click listeners for that text view, or that text view with click listeners. So it can have multiple different reports or issues that you can report on. And this is what the review report item represents. So it represents the issue type, the actual issue as a description, and a suggestion or how you can fix it. And then we have some scanners in the library, which are basically generic classes which are used to scan different types of views. So there's, for example, the general view scanner, which just scans any general type of view. It gives you a list of reports for that view if it has any issues. So in this case, it would be a hard touch or view touch area report, which says, hey, your view area is not large enough. You can't really touch it or click it properly because it's too small. And make sure that your views are at least 48 dp large, and this includes padding, for example. If it doesn't have that issue, then it gives you an empty list, and it just continues forward with those checks. So the idea here is to have multiple different scanners, and then you run through a list of those scanners as using an iterator pattern, and then each scanner gives you a list of reports, and then you combine all of those reports into one single list of issues for that view. So you can scan for a single view for image view issues, for text view issues, for general view issues, and some others, as long as it kind of conforms to all those types, which is represented by the can-scan function. Some of the checks we have here, for example, this is the text contrast check, where we take in a text view and return if the text is large enough and if it has a good enough contrast. So the text size is defined within the system, but also there's an issue where you have to provide two different sets of color contrast values depending on the text size. So if the text is 14 SP and it's bold, then you need to conform to at least 3.0 text contrast. If it's 18 SP or larger, it doesn't have to be bolded. So those are kind of the issues. But if it's just 14 SP and it's not bolded, then it has to be at least 4.5 in the contrast value. So this kind of sounds a bit complicated, but it's actually not as much. You take the brightest of colors, or the brighter of two colors between the background and the text color, and then the darker of the colors, and then you divide them in their luminance value, and you get these values through the operating system itself. There's a property in text views which gives you, or in colors in the system, which gives you the luminance, and the luminance is basically representation of how bright the color is. So in terms of contrast, it should be at least 3.0 for bolded or large text, so to say, and then 4.5 for normal text, which is not bolded or which is not big enough. And this is one of those checks which basically checks if the contrast is good enough, and if not, then it gives you a report saying, hey, you need to improve your contrast in this text or text view. Then when you kind of build all of these checks, you need to scan your views. So what I do here is I just grab the children from the view group that I'm currently in. I get its nested layer, simple views, and all of the basic information I need. And then I also, from that information, I generate a report which holds all of the general data, such as the parent ID, the parent type, its view reports if you have any kind of issues in the view group children. And then if you have nested layers, I do a recursive call and then call scan view for each of those layers to get a full report, a report tree. Now, once this is done, I kind of flatten the report. So I haven't really put the algorithm here because there's a lot of different code and a lot of different algorithms that are at work here. But generally, if you had this kind of a structure, where you have a constraint layout, two nested layers, then within those layers, you might have another layer, which is the linear layout. And all of these layouts have different kinds of views. You would get, through the first pass, you would get a similar report. You would get a first report for the constraint layout, two nested reports for the frame layout and relative layout, and then another for a linear layout. And all of these reports will have different view reports and view report items. As I mentioned, this is really hard to print out, really hard to show to the user. So after the algorithm of flattening the report, what I get is this. I get a single report for the first layer, which is the constraint layout. I get a composite or combined report for the second layer, where we have the reports for the constraint layout and the relative layout or frame layout, which are used, which holds all of these reports. This way, I don't have to print the entire thing in a complex way. I can just print out in a for loop or a while loop or something like that, and I can just go over each of the layers and say, hey, this is the first layer in your UI, this is the second layer in your UI, and this is the third. And then you can use your system, your design tree, or you can just use general XML to check which layers or which layers you have and which issues you have in each of the layers. And does it actually work? Well, when you run it on an application, this is what you kind of get. So the answer is yes, it does work. There are some minor polishing that I still need to do. But basically, you get a similar report to this. This is like a general application that I use for testing. You get a viewer layer 0 report, which is the root layer. You don't have any parent ID or type because it's the root, actually. So you're not really referring to the back part of the hierarchy, which is the Android UI stuff, the window decor and stuff like that. And then you can see here that in the root layer or the zeroth layer, sorry, zero base index, you have a swipe container which contains a circle image view, which has an issue. So the root layer here would be the swipe container. The issue would be in the view which has no ID, which is the circle image view. And the issue would be that you have a content description issue. So either the content description is not there, or it has an invalid description, or like a description which is not really okay, or doesn't really do much to describe what the content is. So such descriptions contain words such as images or photo, which is kind of redundant. So you should clear that up. The other issue you might have in such a view is that there's another view that is that has the ID empty icon, which is an app image view, and it's also within the zero layer, but it's within the empty content linear layout, and it has an issue where its content description is also invalid. So basically, this gives you a list of those reports. It gives you a list of views, a list of parents, and everything that you need to know to find those issues and to clean them up. But there are some issues when it comes to accessibility. There are some things that you just can't really look at, as if it were black or white or yes or no. There are some things that you just have to discuss with other people, and some of the things that you might force or might just ignore. So the problem with the example above is that not all of the images might be important for accessibility. So sometimes those rules are actually guidelines. And I have a really good example here. This is a screenshot that I took a while back of our Discord chat for our Ravenly community. And you can see that the Discord chat is like any other chat. It has a list of people who send some messages. It has those messages, their images or avatars, and a timestamp. So when you look at that, that's what represents every single message. Now, when you look at it closely, the image or the avatar next to the name of the person who sent the message and also the message is not that important for accessibility. Because how would you describe a person through the content description? It has to be really dynamic, and one person might say that I have light brown hair, whereas the other person might have that I have brown hair. The third person might say that I have blonde hair, and it's really, really subjective. So this image doesn't really do anything for accessibility, and it would be great to just ignore it, right? But can you really do that? Well, there are some system checks that you can implement. The system or Android OS offers you two different flags for XML, which are called is important for accessibility and is important for autofill. And these two checks let the system know if your view should be a part of accessibility checks or not. Now, these are used in system checks, but I can also use them in my library, right? So why wouldn't I do that? Well, the issue is that either though you can help the system by saying, hey, this is important for accessibility and this may not be, or you can just decide on your own. This also lets you ignore all of the views that you don't really want to implement accessibility for. So coming from the side of you want to help the system ignore views that shouldn't be accessible, which are not really important for accessibility, you come to a point where you can just disable all accessibility checks for every single view or any of your views. And I'm kind of at a crossroads here where I'm not sure what to do next. And I gave this presentation a couple of times, and basically I ask this every single time. So what do you think what's your opinion on this? Should I force the accessibility checks for every single view, even though the user might put in the accessibility checks that it's not important for accessibility or the flags? Or should you use internal checks instead to ignore any kind of issues that the user might have ignored? Or should I provide a warning instead of just issues? So this is kind of a part where it's really hard to develop accessibility libraries because it's very, very subjective and it's very, very opinionated. And it also depends a lot on your application. So your application might show a lot of images, but if you detect that the user doesn't really care about those images, you don't really need to implement accessibility checks for those images, right? Because the user won't really use them. So it really depends on the person that's using your application, the type of application you're developing, and kind of the community or the general agreement in the community. So definitely let me know what you think in terms of the approach I should take to promote these accessibility checks within my library. So what's next when it comes to the library? I still need to test it across different types of applications, app sizes, so bigger projects versus smaller projects, custom views, fragments, all of these things, and different API levels. I tested it for the most part, but there are still some weird use cases where some views might use some type of reflection where it just changes the entire thing or how it works. So some of the checks I use might not work there. The application is currently backwards compatible with API 21, which is about 85% or more of the market. I'm not sure, I haven't really checked, but it could be more accessible or more backwards compatible. I'm not entirely sure if I need to do this or not, but we'll see. I need to add more quality of life improvements. So for example, in my reports, I would like to add actual colors values or contrast values that you have issues with, or actual descriptions that you have issues with. So if your content description contains a bad word or something that you don't really want to use in accessibility, I can say, hey, this is your description. Try doing this instead or something like that. And I would like to add more handling, more accessibility handling to implement more features and add some possible opt-in analytics. So for example, you can opt in for analytics to report to Firebase Analytics or something like that, the number of reports you have, the types of reports you have. Of course, it will be kind of obfuscated or really simple, just so I can track, what are the most important issues or the biggest issues in most libraries. So I can kind of use this information to try and build some solutions to help you fix those issues, or maybe even contact the development team to try and support more out-of-the-box accessibility solutions when we develop the apps. So there's a lot of different data I can use here to try and sort out all of these issues. Another thing that I want to kind of implement is to add some kind of a way for you to implement your own scanners that you will add to the list of my scanners I use, and then you can scan for custom views or some different things that are really, really useful for your applications, but are not really general or generally defined in terms of the accessibility guidelines. So these are all of these small things that I want to implement. Hopefully by the end of the year, or January or something like that, so I can have a really powerful library that helps out the community develop more accessible applications. And that's it from my talk. That's it from the accessibility side or from the LI side. I hope you kind of enjoy learning more about accessibility. It's a really important topic, but not a lot of people really know much about it or have done some research on it. If you want to reach out to me, keep in touch or something like that, just maybe even help out in terms of developing the application or the library, then you can reach out to me on LinkedIn, Twitter, my personal profile on Ravenly, Gmail, any kind of other social network, or you can jump onto our Ravenly.com Discord server, where we have an open, public, free community of 2,000-3,000 people, something like that, where you just chat about different things, and you can just jump in and hang out with us and ask any kinds of questions, including questions about my library. So thank you for listening, and are there any questions?
Yay, thank you. It was really interesting. And I had one question about like, when you were implementing your thesis, like how did you came up with this idea of your project?
Yeah, so kind of when I started developing applications in general, when I started learning about development and stuff like that, I always had this idea of trying to help out the community, trying to help out users as well, trying to build something that is meaningful, that's actually useful to the community and the general society. And I never really got around to developing such applications, because most of applications we do are client-based applications, which are either e-commerce or some kind of a product for the client. So it's not really community-based. And I realized, I have a thesis that I have to finish, and I want to do something good. So when I started researching a bit about what I can do with Android specific as my area of expertise, and what I can do in terms of helping the community, I found that accessibility is not really supported. There's not a lot of different tools. As I mentioned, only 2 in Android, which are not that generally used. So I just went with it and just try to do my part to help out the community, which I hope I'm kind of doing with this library.
Cool. Yeah, I'm sure you're doing. Thank you. And the question from the comments. Is there any elements in Android UI which was designed as a part of Android OS for people with disabilities?
So I'm guessing the question basically is something in terms of, is there like a view, let's call it accessibility view, that helps users use accessibility? I don't think there is in terms of like a special accessibility view, but every single view or the view class, the base view class, has a lot of different things that you can use for accessibility. So there's this feature or mode that you can support, which is called like focus navigation or gesture navigation, where instead of using your hands to tap on different buttons, you can use different kinds of external hardware controls, where you just focus different views. And it kind of looks like, if you have a PlayStation or like an Xbox or something like that, it kind of looks like that focus feature, where you move around your different icons and you select things on your consoles. This is what happens with the mobile part, where you can select different things and then you can perform clicks through those external controls. Again, there's different things like screen readers, where you can just add different content descriptions or accessibility labels for every single view, and the user can use the system to read out those descriptions. But there's not a single view that says, hey, this is an accessibility view that's going to help you solve all of these issues. Because as I mentioned, different types of views have different types of features and different types of issues they can kind of fall into if you don't implement accessibility. So it's hard to develop something that's very generic, that works for both image views and text views and general views and edit text and everything else, especially when you can just extend the view class and build something completely custom.
Yeah. True. Next one, do Google websites UI UX use some rules for colorblind people?
Yeah, so all of the things that I implemented in my library are actually following the WCAG, or Web Content Accessibility Guidelines, and the Google guidelines for Android applications. So it's kind of a universal thing, where you have basically web guidelines, which are also used for mobile applications. The guidelines also give you UI UX rules for colorblind people. So one of the main rules is, if you have some kinds of images, and you have texts in them, any kinds of text, then you should make sure that those texts have a good enough contrast. So if it's a really light image and you have like a light gray text, you should have an outline on the text. Or if you have two colors which are very, very different, very, they have a really strong contrast, but in a bad way. For example, if you use the color blue, which is like a really, really light blue, really, shiny blue, and you have a specific yellow color, it's not going to look really nice in that contrast. You won't really be able to read it. And in fact, if you look at this screen, what you have is, these are really good guidelines where you have the blue color for the background, and the DevFest letters Central Asia 2020 have an orange color, which is a better contrast compared to the yellow one. It also has like a black border around it, like a really tiny black border, which makes it a bit easier to read. So these are some of the guidelines that you can use to improve colorblind support. Now, when it comes to images, it's also really hard to support contrast for people who don't see colors at all. They just see different shades of gray. So it's really hard to support these colors, and there's no single guideline that you can use here. Generally, it's best to have something like material design, where you have different layers and you can see those layers. So you can see elevation between layers, you can see the shapes and the materials, so to say, used in those images that help you differentiate different parts of the image. So there are some guidelines for text and background color and stuff like that on images. But if you have a single image that's just a bunch of different things, you maybe took a photo of your backyard where you have a bunch of different trees with different colors, it's really hard to differentiate between those contrasts and those materials, because there's just so much going on.
And the last question is, do you know developers with disabilities who does these rules for themselves also?
So I personally don't know about, I don't have many developer friends who have disabilities and use these issues. But a really, really big and really good example is what Google does at their own teams. So at Google I/O 2018, I think, and 2019, we had different stories from Google's developer teams where they showcase how, some of the people who work at Google have disabilities, and they're working towards better solution for accessibility. So in terms of voice assistants, they use a lot of different audio clips from people who had speaking disabilities and weren't really understandable, or the voice assistant couldn't understand them on the front line. They couldn't understand them out of the box. So what they did was they trained different machine learning models to learn how to recognize speech from people with speaking disabilities. So this is one of those really great examples where people who had an issue realized, hey, we can do something about this, and let's try to fix this. And I think all of the big companies who have development teams have some teams where there are people with disabilities which have issues or problems using applications in terms of accessibility. So they're working on better solution within every single operating system to help these solutions. For example, there's another thing that Google did for Android phones where you can turn off your sound for videos, but you can still turn on live captions, which are captions done by in real time, recognized by the machine learning model underneath. So the machine learning model processes the sound without actually playing it, and then it generates the captions for you. So if you have hearing impairment issues or something like that, you can just, let's say, listen to the video by reading through the text. And these are some of the examples that are really popular from Google, from their work, but there are also other companies that do all of these things, but I don't personally know any issues, any developers with issues.
Yeah, and basically that's it. Thank you for presenting. Okay. If you want to add some couple words.
I would like to thank you everyone for coming here and giving me this awesome opportunity. It was really nice to talk about some of the work I've been doing. Again, I think these slides have been shared, or there's a link somewhere, so you'll get the slides. I can also reach out to Begima and the entire organization to share them. So you can just reach out to me as well if you have any kinds of questions. And if you do want to help out with development of the library, it's completely open source on my GitHub profile. So you can check it out, you can raise issues, you can test it out, and just help me make this library even better. And thank you.
Yeah, good luck. Thank you.